Hi, welcome to Intermolecular Forces, Solids and Liquids Part 3. My name is Dr. English, and today we're going to look at dipole forces. Specifically, we're going to look at what are dipole forces, what makes a molecule polar, representations of dipole forces, another representation of a dipole force, and finally, boiling points in dipole forces. So let's start talking about dipole forces. Polar molecules, such as H2S or CH3Cl, are held together as liquids by dipole forces. Dipole forces occur between molecules that contain polar covalent bonds and a geometry that forms polar covalent bonds. The result is a permanent dipole. And before we go on to the next example, let's actually look at the word dipole. Remember, di here means two. The word pole means positive pole and negative pole. So any molecule that has a permanent dipole will have two poles, positive pole and a negative pole. So recall, polar bonds occur when electrons are not shared equally in the bond to differences in electronegativity between the atoms in the covalent bond. Let's look at an example of the Lewis dot diagram of hydrogen sulfide. The sulfur has 6 valence electrons. The hydrogens each have their 1 valence electron, and we can see the covalent bond here and here with the 2 lone pairs here and here on the sulfur atom. If we were to do the structural formula, we'd see it represented like this, where the hydrogens are less electronegative than the sulfur, so they get the partially positive charge, and the sulfur gets the partially negative charge. Hydrogen sulfide has a permanent dipole, where one end is always negative and one end is always slightly positive. Let's see a representation of these dipole forces in action with the molecule hydrogen sulfide. So let's put a bunch of hydrogen sulfide molecules in this box. There they are. In order to see the dipole forces between the hydrogen sulfide molecules, we're going to have the negative end of one molecule be attracted to the positive end of another molecule. And we're going to represent this weak force of attraction with dots instead of lines. Each of these 3 blue dots between each molecule represents a dipole force. And if you look at these blue dots, you'll always see that they range from the slightly negative sulfur to the slightly positive hydrogen between each molecule here. This is one representation of dipole forces. Now let's look at a representation of dipole forces with hydrogen chloride. In this compound, a permanent dipole occurs due to the differences in electronegativity between the hydrogen and the chlorine atoms. As a result, dipole forces exist between the molecules. So let's add some hydrogen chloride to the box. Here they are, and we can see the slightly positive on the hydrogen end and the slightly negative on the chlorine end. When we add the dipole forces in between, again, we can see that these dots go from the slightly negative on one end of the molecule to the slightly positive down here of another molecule. So you have another representation of dipole forces between molecules. Now let's look at boiling points in dipole forces. Dipole attractions are stronger attractions than London dispersion forces. Molecules that contain dipoles have higher normal boiling points than nonpolar molecules of comparable size. Dipole attractions become weaker as the distance between the individual molecules increase. So the farther away these molecules are from each other, the weaker the force of attraction that will exist. We can see this if we look at 2 different molecules. Diatomic oxygen has a molar mass of 32 grams per mole, and it experiences dispersion forces and has a boiling point of 90.1 Kelvin. Compare that to a polar molecule like hydrogen chloride, which has a comparable mass of 36 grams per mole, experiences dipole forces, and the boiling point is much higher at 188.1 Kelvin. Now let's do a practice problem. Which of the following compounds will experience dipole forces between neighboring molecules? So what I'd like you to do is stop, take a moment, reread the problem, look at the answers, select your choice, and come back. Welcome back. Let's see how you did. So let's look at the problem again. Which of the following compounds will experience dipole forces between neighboring molecules? Remember, if you're looking for something that is going to experience a dipole force, you're looking for a polar molecule. Br2 is a non-polar molecule. There's equal sharing between the two bromines, so this is not an option. CH4, methane, is also non-polar, so this will not experience dipole forces. CO2 is also nonpolar because we remember that CO2 looks something like this. This is a nonpolar molecule, therefore it will not experience dipole forces. Hydrogen selenide, though, is a polar molecule. Selenium is in the same group as sulfur and oxygen, so if we were to quick draw this out, it would look something like this, with the two lone pairs coming off the selenium up here. This is definitely polar, as the selenium would be slightly negative, the hydrogens would be slightly positive. Most definitely polar, therefore this is our correct answer. So what did you learn in this tutorial? We went over what are dipole forces. We talked about what makes a molecule polar. We looked at a representation of a dipole force. We looked at another representation that involved dipole forces. And then finally, we talked about boiling points and dipole forces at the end. Need more help? Feel free to contact me. Have a great day.